Okay, illustrative math, Algebra 2, Unit 2, Lesson 10 is called Multiplicity. All right, our goal. I know what multiplicity means. I understand the effect of multiplicity of factors on the shape of a polynomial function, and I can use zeros and multiplicities to create a rough graph of a polynomial function. All right, so first of all, let's talk about multiplicity. Multiplicity is the power to which a factor occurs in the factored form of a polynomial. For example, in the polynomial x minus 1 squared plus x plus 3, x minus 1 has a multiplicity of 2, and the x plus 3 has a multiplicity of 1. Now, I'm going to kind of ruin the surprise of the lesson today, but I'm going to have you write this down as well with your definition. Odd multiplicity crosses through the x-axis, and an even multiplicity touches and bounces back on the x-axis. So for an example here, for that polynomial here that I had, here's my axes here. We know my x-intercepts are at 1 and then -3. Okay, because those are my zeros if I set this equal to y or f of x. Now, we also know our end behavior if I took the x. Now remember, this x minus 1 is really x minus 1 twice. So if I took the highest power on each factor, so the x, 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 and I multiplied all that out, I get x cubed as my first term. I don't really care what the rest of it is. So leading coefficient's 1, degree is 3, so it's odd. So my right side goes up, my left side goes down. But here's the key. At -3, it has an even or an odd multiplicity. So x plus 3 has a multiplicity of 1. So at -3 here, I'm going to cross through the axis. And then since 1 has a multiplicity of 2, it's going to actually just touch it right there and bounce back up. Okay, so it'll look something like that. It's a little crooked here, but it should be smoother. All right, what do you notice? What do you wonder? Well, I kind of ruined a little bit of surprise here, but go ahead, pause the video and take a look. All right, so let's write down some notices. So I notice all expressions have x minus 3 as a factor, and x equals 3 as a 0. And a 0 is an x-intercept. They're all polynomials. The first graph is the only one with a different end behavior. All the other ones are pretty much the same end behavior. Some wonders. How about why do the graphs look so different when the equations are so similar? Equations, or I guess I said expressions earlier. Maybe I changed that to equations. All right. What would x minus 3 to the fourth look like? I notice we only have powers of 3, 2, 3 and 2 on x minus 3. So there's something. What else? Now I already kind of gave this away, but I'll say what determines if the x-intercept crosses through the x-axis or touches the x-axis, or how about instead of touches, crosses through or bounces at the x-axis. I already kind of told you that it's even multiplicity and odd multiplicity. So since I already kind of ruined it, look at this one, even multiplicity for x minus 3. So that means at x equals 3, it's a bounce. Even multiplicity here, so same thing, at x equals 3, it's a bounce. This is odd because this is really to the first power here, right? So at x equals -1, it crosses. Odd multiplicity, so at x equals 3, it crosses through. That's to the first, so at x equals 6, it crosses. This is even here, so at x equals 3, it bounces. Okay. All right, so let's take a look at this example here. My x-intercepts are x equals -9, x equals -3, and x equals 4. Now this 4 is an even multiplicity, so this one's a bounce, and these ones are touches. I'm sorry, not touch, cross. Wrong word. These will cross through. All right, a touch is a bounce. So let's get our end behavior. So we got x times x, and then this is really x minus 4 times x minus 4. So if you take the highest power in each degree, or in each factor, it's basically going to be x times x times x times x. So that'll give you a 1, x to the fourth, and I don't really care about the rest of the polynomial. So left side up, right side up. So this is my end behavior because it's positive, lead coefficient, and even degree. So at -9, it's a cross. So you need to make sure your graph goes through -9. And then at -3, I'm going to cross again. My y-intercept, I probably want to know where my y-intercept is. If I took 9 times 3 times -4 times -4, I could get my y-intercept. Take all the constants. So let me just get a calculator here and see what that is. It's going to be 432. Holy cow, that's going to go way up here. And then here's the thing, at x equals 4, we're just going to bounce. Now this has to be kind of curved. Mine looks a little sloppy there, but that's a rough sketch of the graph, okay? And you know your y-intercept's up here at 432 because I multiplied the constants. Just don't forget this, when it's -4 squared, you really have two -4s there. All right, so here's some examples. We're going to find the degree. So to find the degree, you take the highest power in each factor. So my first term is x cubed. I don't care about the middle ones. I do want to know what the y-intercept is. So I'm going to multiply so here, let's do this. The x cubed comes from these being multiplied. And then the constant is going to come from these being multiplied. So that will give me, when I multiply those, I get positive 32. So I know my y-intercept's up here at 32. End behavior, left side down, right side up. So my degree is 3. My zeros are -2, 2, and 8. since I have odd multiplicities on all of these are all going to cross through. So I'm going to put them on the graph. Here's -2, here's 2, and here's 8. So I'm going to go up here because this is the end of my graph. I'm going to go down. I'm going to go up here and make sure you cross. And there you go. So I maybe make sure you put a little note here if it crosses or bounces. I'll put a C or a B there. All right, over here. I'm going to write it out like that just so you can see it. So if I take, all right, let me do it in the same color. If I take my highest power in each factor and I multiply it, I'm going to get -x cubed. I don't care about the middle terms. Just to see what our y-intercept would be, let's multiply. Really, it'd be this as well, because that is a constant. It's -1. My y-intercept would be 4, 8, -8. So be -8 right here. And this came from multiplying all the green. So you can kind of tell here your end behavior here, left side up, right side down. So your degree is still 3. Your zeros are x equals -2 and 2. Now, since -2, now -2 comes from this factor here, the x plus 2. So that's a multiplicity of 1. So that's going to cross. And then this 2 comes from the x minus 2 factor. Since that's even, that's going to bounce. Okay? So I'm going to put my -2 on the axis and my 2 on the axis. My y-intercept is down here at -8. So I'll put that right there at -8. So I know the left side's got to go up. So I'm going to go far left. And I'm going to go down here. I'll make sure I bounce. And I keep going down because I don't want to cross again. So the graph would look something like that. Now let's check it with the actual graph. So looks pretty close. Now we don't know where these relative max and mins are going to be because you need calculus to do that. So I'm not too worried about that. Same idea over here. Looks like -8 is my y-intercept. I'm a little off with how deep I went and my graph is a little sloppy, but same general shape. My x-intercepts are correct as well. So again, remember this is x plus 2 times x plus 2. So if I multiplied the x's, I get my first term is x cubed, and my y-intercept is 24. I don't really care about the middle. Degree is 3. My zeros are -6 and -2. -6 has an odd multiplicity, so that's going to cross. -2 has an even, so that's going to bounce. Oh, you know what? On the last one, I didn't finish my end behavior. I guess I talked about it. I said up and down on the left. So as x gets larger and larger in the negative direction, I would just say y gets larger in negative direction. And then I guess I would also have to say as x gets larger in positive direction, y gets larger in positive as well. As x gets larger and larger in the negative direction, I'm going left. Y gets larger in the positive. And as x gets larger in positive direction, y gets larger in negative. All right, so over here, my picture looks like this. So as x gets larger and larger in the negative direction, so that's as I go left, y gets larger in negative. And then as x gets larger in positive, my y goes up. So y gets larger in positive as well. All right, so let's get this plotted here. I got a 0 at -6, and I got a 0 at -2. So the right side goes up, so I got to go up here. The left side goes down, so I'm going to go down here. So here's the thing, though. At -2, it's a bounce. So I have to cross here at -6, so I'm probably going to have to do something like that. Okay? Plot your zeros, put your end behavior on, and then figure out your bounces or your crosses. Here my zeros are -2. Right here, that's a cross because it's an odd. -6 is a bounce. This is going to give me -x cubed for my first term. I'm not even going to worry about the y-intercept on this one. So let's see here. My x-intercepts are -6, -2, same x-intercepts. Odd and negative is that way. So I'm not going to even write this in here just for the sake of time. So I'm going to just worry about sketching this. So we know left side up, right side down. Now here's the thing, -6 is a bounce. So if I'm coming from this direction, I got to bounce back up here. And then this one crosses through. Let's check these. Looks pretty close. Also looks pretty close. All right, make sure your x-intercepts are right, make sure your end behavior is right, and then make sure bounces and cross through are correct as well. All right, so this is going to be 3 x's. So think of it like this. So if I multiplied all the highest powers in each factor, I'd get positive x to the 4th plus whatever. Degree is 4, and it's a positive leading coefficient. So left side up, right side up. My zeros are -4 and 2. And they're both crosses because they're odd powers, odd multiplicities. So I know both sides going up. And I have to stay down here. I can't cross again. So, I might do something like that. Or maybe I'll have something just like that. Either way, we don't really know. Over here, if I take the x cubed times x times, this is really x squared because you're going to have x minus 3 twice. I get 4, 5, 6. I get x to the 6th plus whatever. So this is a positive and even. This is the same idea as the last one. Both sides are up. Degree is 6. My zeros are 0 from here. And since this is an odd power, it'll cross. -4 here. And again, this is to the first, so that is going to cross. And then +3, and that's going to be a bounce. So I put my 0 there, my -4, and my 3. I know my end behavior. And we cross at -4, we cross at 0, and then we bounce. So let's take a look at these graphs and see how they came out. Well, a little off here on this, but I have no way of really knowing that. I know that my end behavior is right because the left side goes up and so does the right. I cross through -4, I cross through 2. I just don't have any way of knowing what that looks like in between. So, it was a good estimate there. And then here, -4, cross through at 0, touch at 3. So we have a rough estimate, very rough, but we're starting to get some things to look like the graph should. All right, create your own polynomial for your partner to figure out. Create a polynomial with degree greater than 2 and less than 8 and write the equation in the space given. Trade papers with partner, then fill out the information about the polynomial. All right, we're just going to do one here. It's important that you do this in factored form. I'm going to do that. So this is going to be x squared from this term, and this will give you x cubed. So when you multiply it all out, you end up with 1x to the 5th. So positive and odd, left side down, right side up. If I were to sketch this graph here, I'd make sure, your x-intercepts or zeros are 1, and that's a bounce, and -2, that's a cross. So at -2, we go right there, and at 1, we bounce. So this side, the right side up, left side down. So at -2, we cross through, at 1, we bounce. I'm not really putting any y's on there because I really have no way of knowing where that relative max is without doing calculus. All right, sketch a graph for polynomial function that has 3 different zeros and f is greater than 0 for all. F of x is greater than 0 for all values of x. So we need to have an even polynomial. Let's find some zeros here. I'm just going to say 6, 2, and -4. So I got to have x plus 4 as a factor. Got to have x minus 2. And I got to have x minus 6 as a factor. Now I need this to go up and this to go up because it won't, my f of x would not be greater than 0. It would be negative if it was not greater than or equal to 0. So basically I need everything, all these zeros have to be bounces because if they cross, they're going to be negative. So I need these to be even powers. So I'm going to put 2, 2, and 2 on here. That way it bounces up, and bounces up. I don't ever become negative. So I think the smallest degree I could get away with doing this would have to be 6 because I'd have x squared, x squared, x squared to be x to the 6th. So here's, I guess I did the third one kind of as I worked it out. So here's a picture of my graph. Here's the answer. So I guess this would be 1, this would be 2, and then this would be 3 right here. Okay. We have a 4th degree polynomial with only 3 unique factors. What must be true about the multiplicity of the factors? So you got 3 unique factors. I'm just going to make up numbers here. But your degree is 4. One of these is going to have to be squared. Okay. So what must be true? I would say one of the factors must have a multiplicity of 2. If you changed which of your factors had a multiplicity of 2, how would the end behavior of your graph change? That wouldn't change anything because you'd still have a positive, you still have the same leading coefficient. Your degree would still be the same, and the lead coefficient Okay, let me show you here. So like here, I do x times, really this would be x squared, because it's, remember, it's x minus 4 times x minus 4. So it's x times x times x times x. So we get x to the fourth. Positive, it's a 1 in front of there. So left side up, right side up. If I changed it to x minus 1 squared times x plus 3 times x minus 4, you'd still get x squared times x times x. You'd still get the same thing. You get 1x to the fourth. So you'd have the same end behavior. What's one number you could change in your equation that would result in a graph with a different end behavior? Well, if you changed of any power, that would change your end behavior. So if you change the multiplicity, so if I maybe added a power here, that would now make 1x to the fifth for my first term. So that would change it so that it looks like that. That would work. Or you could put a negative in front of it, or something like that to change the sign of the leading coefficient. All right, so if I just put a negative in the front, or if I put a negative in front of any of these x's, that would change it as well. Actually, this one it wouldn't, because you'd actually have a negative x times a negative x. You'd still get a positive x squared. You'd only have to change one of these. So cool. I know what multiplicity means. I think so. I understand the effect of multiplicity of factors on the shape. I think so. And I can use zeros and multiplicities to create a rough graph of a polynomial. Yes. All right, use the information provided to sketch a possible graph for the polynomial function described on the provided axis. So degree is 4, and we have 3 zeros. So if x minus 3 is a 0, x plus 3 is a factor, x minus 4 would be a factor, and x minus 6. Problem is I'd only get x cubed here, so I have to put a squared on one of them. I'll put it on the 6, or the x minus 6. I'm going to plot my x-intercepts first. In this case, left side up, right side up. So my end behavior looks like this. And let's see here. At 6, we're a touch or a bounce. And the other ones we cross. Okay, because this would be a bounce with the equation I made, because it's got an even multiplicity. And these are cross throughs. Okay, hope you enjoyed the lesson. Thanks for watching.